Hey everybody, welcome to today's lesson. Today we're going to be talking a little bit about the properties of metals, nonmetals, and what we call semimetals, also known as metalloids. So as you can see on your screen here, I've included 5 images of metals. Our first metal that you see is a gold bar. The second is a pair of silver earrings. The third image is aluminum foil. A lot of us probably have that in our kitchen. Okay, the next is going to be a picture of, or I'm sorry, the furthest is a picture of iron, and the other is a picture of my favorite element, molybdenum. M-O-L-Y-B, molybd, and molybdenum. Spelled a little crazy, but I thought it's cool to include one that maybe we're not quite as familiar with here so we can take a look at it. So all of these metals have quite a few things in common with one another. Now, I also want to point out that there are certain properties that obviously are distinguishable by gold, silver, aluminum, molybdenum, iron. One of those, for example, being density. None of them have the same density to one another, but they do have a lot of properties that all metals have in common with one another. So today we're going to talk a little bit about those. Now, the first thing that you might notice right off the bat about all of these metals is that they're really shiny, okay? And so metals typically have the property of luster, okay? Luster, which typically means that they are shiny. Now, I did not include any group 1 or alkali metals into this conversation today because remember we mentioned that they are extremely reactive, and if I were to take them out of the oil that we keep them in, then they're going to instantly react with the air and they would actually lose that luster right off the bat. So even though they are classified as metals, they aren't the best example to look at for the luster, though they are lustrous before they are exposed to air. So the next property that I want to talk about is a term that maybe some of us have heard of and some of us haven't. So metals have this really cool property known as malleability. Malleability, or that they are malleable. Okay. And so this property we did briefly talk about with the gold foil experiment, which is partially why Rutherford used gold in that experiment. And this is the idea that metals, you can actually take them and you can make them into thin sheets. Now, you might have also heard the term malleable, saying that that means that you can be easily molded, which is another way to kind of use that terminology. But for chemistry, we say that malleable is the ability to be made into thin sheets. Right? And that's partially too why I liked including this image of aluminum foil. It is already pounded into that thin sheet. The next term, which maybe some of us are familiar with and some of us aren't, is ductile. Ductile. And that term of ductility or of being ductile indicates that we can make wires out of it, okay? So ductile means that wires or can be formed into wires. Now, not all metals are used in wires because, again, as I mentioned, we do have varying properties of metals, and so some of them are better to form into wires, some of them are not as good to form into wires. For example, I would probably not create an aluminum wire, and I would probably not create like an iron thin sheet, okay? So they have the ability to do this, but it's more about the practicality of some of this too and the other properties that they have. The next property that I want to put down is that they are considered conductors. Metals are conductors. Again, with varying abilities, but they are all conductors. And this isn't just a conductor of electricity, they're also conductors of heat, meaning that they will heat up very quickly, right? There's a reason why we use metals when we are cooking, like metal cookie sheets when we're baking or metal pots and pans. It's because they conduct the heat really well. So they conduct heat and electricity. Okay. The last thing I want to point out about metals is that most metals, almost all of them, are solids at room temperature. Okay, so they are all solids at room temp, which tells us that they all have fairly decent melting points, decently high melting points. Okay, the only exception to this, and there's only two liquids that exist on the whole periodic table. The only exception to this is mercury, element Hg, which is a liquid at room temperature. Okay, cool. So now that we've learned all about metals, I now want to take a little bit of time to talk about the properties of nonmetals. So let's go ahead and flip to our next sheet. So up top here, I have different nonmetals. So these are going to be the properties of nonmetals. And up top, I've included 5 solids that are nonmetals. Now, again, most nonmetals are actually not in the solid form, or I would say they vary a lot more. So for metals, they're almost all solids. For nonmetals, they actually vary. There's some solids, a lot of gases, and again, only one liquid, okay? But just for comparison to the metals, which are solids, and also because taking pictures of gases is much more challenging, I've only included examples of solids here. So let's go ahead and label these. So this first solid, this yellow one, this is sulfur. Our second solid, the red one, is phosphorus. Okay, this third tall looking one, that's actually carbon. Okay, this fourth one, the crushed up looking one, is iodine. Okay, and the last one that I've included, I am blanking on which one I picked. Let me just go back into my notes and take a look. Selenium. I wanted to call it astatine because they do look similar, but we're going to talk about astatine in just a moment. Okay, so here we have our nonmetals. So what properties do nonmetals carry? So nonmetals are non-lustrous. As you can see, a majority of these are not shiny. Okay, so they are non-lustrous or not lustrous. And again, you do see a little bit of shine with carbon and iodine, but again, mostly not lustrous. We don't consider them shiny at all. Okay, our next property for nonmetals is that they are not malleable. Okay, they are not malleable. We cannot take these and pound them into thin sheets of matter like we can with the metals. Okay, the next one is that they are not ductile. You might be saying, this is an interesting list. Is it just completely the opposite of metals? Pretty much. They are not conductors. Okay, so not conductors. Okay, and they are not, they're not mostly solids, which we'll talk about again in just a moment. But I do want to just kind of circle back to this concept of not malleable and not ductile. There's a reason for that. In both malleability and ductility, we have to kind of be able to mold these objects. And the reason that the nonmetals are not moldable like that is because they are what we call brittle. Okay, now you may have heard this term brittle. There's a couple places you may have heard it. So brittle being like peanut brittle, if you've ever had that, it breaks very easily. I usually use a really like awful example in class of saying that old people have very brittle bones. As you get older, your bones break very easily. So that term brittle means that it breaks easily. Okay, so these are going to break very easily. They are not super moldable like the metals. Okay, again, as I mentioned before, I'm going to say most are gases or solids. And again, there's only one example that's a liquid. And our liquid for the nonmetals is actually bromine. Okay, our liquid for the nonmetals is bromine. Okay, cool. So these are our nonmetals. Essentially, you can almost think of it, like I said, as just opposites of metals, though the term brittle is really important to understand. And again, I like to point out that we do have this liquid that is bromine. Okay, so now that we've covered metals and nonmetals, which make up the majority of the elements that exist in nature, I do need to quickly talk about a very special group, which are known as the semimetals or the metalloids. So these are going to be the properties of semimetals, or again, also known as metalloids. Okay, now with these properties of semimetals and metalloids, I did include two images here of two different examples. The first one that's a little bit more shiny is silicon, and the second example is the acetine. Okay, now looking at the images, you'll notice that silicon and acetine don't really look like they have too much in common with one another. And that's really because these semimetals or these metalloids have a really large variety of properties. So some of them are lustrous and some of them are not. Some of them are a little bit more malleable than others, and some are brittle. So these semimetals, we don't really have like any distinctive properties that we need to note, but we do need to note that they share the properties of metals and nonmetals, which is why they're called the semimetals. So they share the properties of semimetals, or I'm sorry, of the metals, getting ahead of myself here, of metals and nonmetals. So as you can see, for example, silicon is a lustrous object, right? A lustrous semi-metal, but it does not necessarily conduct very well. So it has that property of the metal, but then it has the property of the non-metal as well. So looking at our periodic table, I just wanted to take some time to quickly just point out that how we're going to be able to essentially distinguish the different components here, right? Where are the metals, where are the non-metals, and where do we find these metalloids? So interestingly, almost all of our elements that exist on the periodic table are considered metals. So if I wanted to color code this, my metals are going to go from all the way over here with lithium, beryllium, right? The alkaline metals, alkaline earth metals, and they travel all the way through the transition metals, which we've talked about, okay? Those are definitely all metals, okay, metals. And then I do want to take a moment to just show you the non-metals. So our non-metals, okay, are going to be over here to the right side of the periodic table. Okay, that includes this helium, this noble gas, that includes this this halogens group, and then things start to get a little bit tricky, okay? And so we have this little small section of our periodic table where we need to see where are the metals and non-metals and metalloids. And so there is kind of a distinctive way for us to note that. And there is like a mini staircase. Now on your periodic table, it's actually much easier to see. They have that line bolded, but we really need this line, and I think my pen tip is too thick, so let me just change that. So we have this line that goes here, 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 all the way down to here, okay? And this staircase is really important because this is going to distinguish where we find the semimetals or the metalloids, okay? So on the staircase is where we're going to find where we're going to find all the metalloids, but there are two exceptions on the staircase that do not include the metalloids which first and foremost, we gave the example of one of these, which was that of aluminum, right? So aluminum is not a metalloid. It actually just falls in as a metal. So it is one example of an element on the staircase that's not a metalloid. And then our other example of something that is not a metalloid is going to be polonium. It is radioactive. We don't really kind of call it a metal or a metalloid. It's just a radioactive substance. It's closer to a metal. Okay, looking at the remainder of the objects here, everything else that falls on the staircase is considered a semi-metal. So for our semi-metals, we have boron, okay, silicon, germanium, astatine, antimony, and tellurium. So these are going to be our metalloids. They definitely make up way less of the periodic table. So again, this purple is going to be the same thing as our metalloids or semi-metals. Okay, and now the question is, what about all the things that are left out as white? Well, anything that falls to the left of the staircase, anything that falls to the left is considered a metal. So now we can go ahead and we can color in the remaining elements like zinc, okay, and lead, which is Pb. All of these are considered metals as well, okay? And anything to the right of that staircase is going to be considered a non-metal. So carbon, nitrogen, oxygen, sulfur, phosphorus, and selenium. Okay, so again, these are going to be our, let's label this really quick. These are our metals. Okay, and our pink represents our non-metals. And the purple represent the metalloids. Again, we don't really focus on this bottom. So since most of these are radioactive elements anyways, I'm not going to go even talk about those. We don't need to know that for right now. Okay, so we now know how to find metals, non-metals, metalloids using that staircase. Last thing I want to cover is you may or may not have noticed on that previous diagram that I actually did not color in the hydrogen. Now, interestingly, you might have noticed that hydrogen is located in the alkali metals, right? So H is in group 1, which again is the alkali metals. But based on what we've learned about metals, that they're ductile, they're solids, they're shiny, they have luster, they're malleable. Is hydrogen a metal? And the answer is no, right? Hydrogen is not a metal. Hydrogen's a gas. It is fully a non-metal. So why does it belong in that group 1? From yesterday's conversation, right? Remember that H has 1 valence electron. And so that indicates already why it is placed in that group. But I did also want to take a moment to talk about the chemical properties. So hydrogen is actually extremely reactive, and a great example of this reactivity is the Hindenburg disaster of 1937. Okay, Hindenburg of 1937. And this was actually a like innovative large, well, it had been built before, a smaller version of this, but Germany built this really large version of this blimp, and they had it come all the way over from Germany, and it actually was supposed to land right over in New Jersey. And as you can see, that landing didn't really happen. The whole inside or interior is made of hydrogen. That's how it's blown up. Not all of it. There are people, there were about 100 people on board, but the fuel for it is all made of hydrogen, or what's lifting it essentially is made of hydrogen. And again, in order to have the fuel burn, there is fire involved. Now, hydrogen is extremely flammable. And remember we said yesterday too, group 1 is extremely reactive. Okay, group 1 is very reactive. And so when this spark, must have been a spark inside of Hindenburg, and what happened was that blimp went up in flames almost instantly. And I'm going to include a video in today's lesson, which is really sad. But again, it's located in group 1 because of its 1 valence electron and the reactivity, but please don't be confused. It is not a metal. I should have colored it. It's considered a non-metal. So on yours, if you do take notes and color, please make it a non-metal. Sorry for the lengthiness of the video, everybody. I thought it would be a short one, but I just had too many cool things to talk about. So as always, I will see you tomorrow.